In this video, I show you something, obviously. It's a LM741 crystal oscillator, and here I have two types of crystals. Here I have one that most of you may know. It's a classical old 2-pin big size crystal, and this one is special because this is on a long wave frequency. It's on 256 kilohertz, and it's very unusual to have a crystal on 256 kilohertz. And these two, this one and the one you see here, are a different type of crystal. I did not know that myself until I learned it. I learned it the hard way, so to speak. And I'll talk about this in this video. So, this crystal, if I put it into the circuit, it will oscillate at the said frequency. I can do that, I must detune the radio. It also works with this crystal, but there is something about it. So, as you can imagine, crystals for medium wave, like 1 megahertz or something in that area, is very hard to find nowadays. And if you find it, the seller wants a lot of money because the seller isn't stupid. The seller knows it's a valuable thing, so I want a lot of money. Let's say you buy a 20 megahertz crystal. It costs maybe 10 cents, 20 cents. Let's say you want to buy a 1 megahertz crystal, one of these old ones. You buy 10 bucks. Buy it for 10 bucks because the trader knows it's a valuable item, it's rare, and I think based on that you can imagine how much you have to pay for a long wave crystal that's on a long wave frequency. Well, I was lucky. I didn't pay a lot for it because it was in a collection of a lot of crystals. But then, or I think it was earlier, I found something. On the well-known auction site, we all know, I found these here. The seller says it's a crystal on 240 kilohertz in a long wave band. And he sold 5 or 10 pieces for 3 bucks. So I said, hey, come on, it's so cheap. I'm going to buy it instant. And I did that. I bought them. I bought even more of them. I have a whole bag of these. And when they arrived, I was curiously putting them into my default crystal oscillator. Pierce oscillator, 1K from collector to plus, 100K from base to collector, and everything connected to a 9-volt battery. This is your typical quartz crystal oscillator. Of course, you need 2 capacitors, one from collector to ground and one from base to ground to make it oscillate. Puts out a few milliwatts, works very well. Well, I played I think an hour or so with these crystals, and no matter what I did, I was not able to get them to work. They were just there and not doing anything at all. If you know how these things are built, you will notice a difference. These are built, if you open them with a Dremel, you will find that both leads inside go to leads inside the quartz crystal, and there is this round-shaped object in the middle. It's a bit like a capacitor, by how it looks like a ceramic disc capacitor. Of course, it looks different, but for your imagination. Imagine this, and this is how these crystals work. And you can use them with some power, like 250 milliwatts, they can handle it. The taller crystals can handle a bit more, I suppose, but the typical crystals, the HC49U, I think they are about 250 milliwatts maximum power. If we look at this crystal, you can't see it on camera because today the filming isn't too great. I had my reasons why this isn't in the best quality. It's a compromise how I film it. But if you look at this, I can explain you what I see. I mean, it has a window. It has a window in front of it saying the frequency, which is 240.000. Then it says the producer, which is MC. And then there is the letter V. The letter V is printed on it. And it's all that's on there. But if you look into it, you cannot see this round-shaped object you see in a regular crystal. Instead, you see brass-looking things, 3 of them. There's one long line of brass in the background, and 2 of them, parallel, are in the front, which are thicker and well visible. So this is definitely something else. And I was building my crystal oscillators and playing around with these crystals, and no matter what I did, they didn't oscillate. I was already a bit angry because I paid some money and have a lot of these here, and now I can't use them, I thought, until I removed the crystal from the circuit board and looked at it and saw that it was physically broken. So these staff things that are fixed inside, they were loose inside. You could shake it like a rattle and they would just fall around inside the crystal. And I said, oh, well, the crystal is broken. Of course, it can't work. And I put in another one, turned on the circuit, put on the power, and again, nothing. Until I removed the crystal and found out that again the crystal is broken. So obviously something in the circuit is physically destroying this crystal. I was like, what's going on here? What's going on with this crystal thing? And then I talked to my friend who also is into electronics and knows a lot, and he explained me what I didn't know before. There are two types of crystals. One is the regular one, we all know, and the second type, which is this one, is would say mechanically crystal. So instead of having a quartz crystal, the stone-like material, this is like if you play an instrument, you do this ding, and it makes a constant tone to tune your instrument, something like this. And these crystals work similar. So there's very tiny instrumental steps inside to generate the frequency, but hence they are very tiny. They are also very sensitive to electrical current. And if you drive too much current through them, you physically break them. And this is exactly what happened with my crystals. The current that was driven through them was so high that it physically broke apart this thing inside. And I also noticed something because I had my radio tuned and had it on and connected the crystal oscillator, and for a part of a second, for a very short time, it did oscillate. I got the signal very short, but in less than 1 second, the signal was gone again. Remove the crystal and it's broken. And this is what I want to say when I say that I learned it the hard way, that these crystals are very sensitive. You can use them, and these circuits here, this is like a microcontroller, microchip something, also has one of these crystals, probably a 32 kilohertz crystal. It doesn't say a frequency on it, but usually it is for a clock, because this probably also has a clock. And these are also like these crystals. You can use them, but you must use them with extreme high impedance, extreme low power, and then, as you can see here, it's already transmitting on 240 kilohertz, because here you can see the other part that I've put in. There you can see it is working really well. So, if I push play, you know these commercials already. You can hear them being broadcasted via this circuit using a 240 kilohertz crystal. Here's the schematic of the circuit, of course. And it uses the LM or UA741 op amp, which is vintage and very old, but I decided to use it. I played around with these crystals. I managed to build different circuits that also work, but I wanted to have it this way. I wanted to use the op amp, I wanted to have it this way. And you notice something. Here is the crystal, the 240 kilohertz, and you noted that in series, you notice it's a very high impedance circuit. We have a feedback with 10 mega ohms, which is extremely high, and the crystal is coupled with only 3.3 picofarads. This is basically close to nothing. It's like you take two wires and wrap them parallel and you have 3 picofarads capacitor. This is how loosely everything is built here on the feedback circuit. This is the minus, this is the inverting input, this is the non-inverting input, and the other circuit is default. Without it being a new IC, it's an old IC. The UA741, unlike most new op amps, has two pins, pin 1 and pin 5, that allow you to access internal parts of the IC. To be more on the point, it allows you to rebias the IC. And what I'm doing is I'm adding the audio signal here on pin 1, rebiasing it using the audio signal, and this generates an amplitude modulation on the output. You also could modulate it on pin 3, but you would have to change these resistors. I tested it, it does work. You have to change the resistors and then you can modulate it on pin 3. Okay, of course I could remove the crystal now, the 240, and put in this other one. Now something is not having a good contact. It's a bit loose here, and you knock on the circuit board and it works again. Anyhow, if I would put in this one, trust me, it would work. I showed it in another clip because I'm retaking this over and over to have the good clip. But yeah, so this was about crystal oscillator. First, you have your LM741 crystal oscillator here. You can rebuild it if you want. I suppose it works with low frequency crystals. Maybe it does work with a 1 MHz crystal, but this op amp is very slow. So higher frequencies like shortwave, I doubt it's going to work. You can try it though. I didn't test it. I just tested it with this, and it works with both. But this is long wave, and this is, I think it's within the capabilities of this IC. Anyhow, so this was about the oscillator, and that there are two types of crystals, the regular one that can handle a lot of power, if you want to call it like that, and the other one that uses a staff construction to make the frequency, which is very, very sensitive, and it's a bit tricky to get it in an oscillator that it works. Okay, so this was my video about these crystal oscillators. As always, I appreciate your time. Greetings, Stefan.